Hello everyone, welcome back to our YouTube channel schoolquiz.com. My name is Danish Agarwal. So today's our topic which we are going to discuss, that is numericals based on mole concept. In our previous video I have taught you about the formulas which were we going to use in this in these numericals. Okay, so first of all we will discuss our three formulas. First one is n equal to, that is w upon n, and n equal to n upon na, or we can write it as n naught. And third one is by equating these two, that is w upon m equal to n upon na, n upon na. So we are going to discuss our numericals on the basis of these three formulas. So I will note it here: 1, 2, 3. So our topic is numericals based on topic mole concept, which is at page number 41, in your NCERT book. These numericals are very important from the paper point of view also. Okay, so first one is calculate the number of moles. First one is calculate the number of moles. Calculate the number of moles for the following. First one is 52 gram of 52 gram of helium, and second one is 12.044 into 10 raised to power 23 number of helium atoms. Number of helium atoms. Okay, this is our statement. So first of all we will read it again. First one is calculate the number of moles. Calculate the number of moles. So number of moles, calculate. We suppose we have to calculate small n for the following. First one is 52 gram of helium, which says W. If we solve the first part, suppose n we have to find, and given weight, that is, suppose we consider it like W, that is our 52 gram. Weight is given. Molecular mass I have already discussed. Four molecular masses mainly: helium 4, carbon 12, sodium 23, oxygen 16, sulfur 32. So as we know, molecular mass of helium is 4. Now we have these three formulas. And we will see. Suppose if we try to put our first formula, is this satisfied? Suppose if we say n we have to find, w is given and m as we know. So we will apply our formula number 1, that is n equal to w upon m. So simply we will put that is w equal to 52 and m is, that is 4, which implies cutting कर देंगे. 4 1 is 4, 4 13 is the 12. So number of moles comes out to be 13. Very simple question, guys. Very simple question. As we already know that most of the students are afraid of numericals, but these numericals are very simple. First of all, you have to read the statement carefully and mark, like calculate the number of moles for the following. First, mark here that number of moles we have to find, it is small n. Next, 52 gram of helium, which means W is given, that is 52 gram, and helium molecular mass, as we already know, that is 4. So simply we have to put the values and we will get the value of n, that is our 13. So note it down. Okay, now we will move to a second part. I will raise it. Second part, as you practice numericals more and more, you will able to know which formula will we have to go into, which will we can apply. Okay, now next is, if we say n we have to find, in this case n naught is given, that is number of particles particles, 12.044 into 10 to the power 23, and m, as we already know, helium atoms. Helium atoms. That is helium. That means molecular mass will be 4. Molecular mass will be 4. Now we will apply, that is n equal to n naught upon Na. N naught upon Na. We will apply this formula because we don't know W. We don't know W, and Na value we already know. That is Na is what? That is 6.022 into 10 to the power 23. And we can already see that it will be cutting easily. Okay, we will apply like that is 12.044 into 10 to the power 23 divided by 6.022 into 10 to the power 23. Okay, as we see 10 to the power 23, 10 to the power 23 same, cancel out, and 6 1 is 6, 6 2 is 12. So answer comes out to be n equal to 2. N equal to 2. So this is very numeric. This is very easy numerical, guys. It's just simply we have to put the values and then we able to know our answer. So this numerical is very simple. Okay, now we will move to our second example, that is example 3.4. Example 3.4. Example 3.4. Okay. The next is calculate the mass of the following. In which we have to calculate the mass. Calculate the mass of the following. If we say mass, that we have to find W. Okay, we have to find W. And first part is, this question has 4 parts. First we will discuss first 2 parts and then we will discuss next 2 parts. First one is 0.5 mole of N2 gas. 0.5 mole of N2 gas. So first part is 0.5 mole of N2 gas. As we know, molecular mass of nitrogen is 14. But here N2 gas. Here are 2 atoms are present. N2 means 2 atoms of nitrogen. 2 atoms of nitrogen. When gas what is given, which always means 2 atoms. Almost. Like oxygen gas, which means O2, nitrogen gas, that means N2, bromine gas, Br2, iodine gas, I2. So we have to carefully notice that atoms are given or we are given with gas. So here gas is given, which means we have to take 2 atoms. Which means 14 multiplied 2, that is 28 is our molecular mass. 28. So we will discuss. In this case we have to find W. N is given, that is 0.5, and molecular mass is 14 into 2, that is 28. If nitrogen atom is given, then we will take 14. But here N2 gas is given. Which means there are 2 atoms. There are 2 atoms. Okay. Now we have 3 formulas. N equal to W upon M, N equal to N naught upon Na, and third one is what? That is equating by 2. I hope now you remember the formulas. I hope now you students remember these 3 formulas. Okay, we will think that which formula we have to use in that numerical. Okay, if we apply first formula, that is N equal to W upon M, N is given, W we have to find, and we have M, but we have to find W. Suppose now we will apply, that is N equal to W upon M. Simply N equal to W upon M. N is given 0.5, W we have to find, and M is 28. 8. Simply calculation then. Then simply is calculation. Suppose here is 1 and cross multiply. Then W will be equal to 0.5 into 28. 0.5 into 28. We will regard it as 1 by 2. As we know 1.5 is 1 by 2. So 1 by 2 into 28, that is 2 on this 2, 14. Then weight comes out to be 14 gram. Weight comes out to be 14 gram. Very simple question. N is given molecular mass as we know. Then W we have to find. So just we have applied the first formula. Okay. Now we will move to our second part. Second part is second part is second part says 0.5 mole of nitrogen atoms. 0.5 mole of nitrogen atoms. Now same thing, we have to find W. Number of moles equal to 0.5. Now one thing we have to notice, now it is given nitrogen atoms, which means we have only one atom of nitrogen that will weigh only 14 gram. That will weigh only 14 gram, or we can write 14 gram. So here we will apply formula. Now we will think which formula we have to apply, which will satisfy our needs. That is, N is given 0.5, N is given 0.5, W we have to find, and molecular mass we know, that is 40. So we just apply N equal to W upon M, and N is 0.5 and W is we have to find, and M is 40. So we just cross multiply, and W equal to 0.5 into 14, and we will regard it as 1 by 2 into 40. 2 on this 2, 2 sevens are 40. So weight comes out to be 7 gram. So weight comes out to be 7 gram. Okay, very easy question, guys. This numerical is also very easy. Okay, now we will move to a third formula. Third part is 3.011 into 10 raised to power 23. 3.011 into 10 raised to power 23 molecules of nitrogen atoms. Okay, so nitrogen atoms, first we will discuss that M is 14. Not 28, M is just 14. Okay, and number of particles is given 3.011 into 10 raised to power 23, and W we have to find. Okay, now our these formulas are N equal to W upon M, N equal to N naught upon Na. I am writing again and again only for you students, only for you. Okay, that you will think what was the formulas. Then W upon M equal to N naught upon Na. This one is our third formula. And just now see, we have to find W. We have N naught and we have M, that is 40. M is 40. Now which formula we will apply? Suppose we have to apply W upon M. N we know, we don't have N. We don't have value of N. We don't have value of W. So how can we apply the formula? So we can't apply the formula number 1. Now we will move to formula number 2, that is N equal to N naught upon Na. N naught upon Na. Now we have to calculate W, and in that case W is not here. So we will apply our third formula. In this question you can see, when we are not able to use our first formula, not second formula, then we will go to our third formula. Okay. So we will apply our third formula. We have to calculate W. So according to situation, we will manipulate that formula. That is, W will be equal to what? That is N naught into M upon Na. Third formula is very important. Okay, W we will calculate, then W will be equal to N naught into M upon Na. And as we know, Na is what? That is 6.022 into 10 is power 23. 10 is power 23. So N naught is 3.011 into 10 is power 23 and M is our 14 and Na Avogadro number, that is 6.022 into 10 is power 23. So we will cancel it out. This one 1, 2, 1, 7. So weight comes out to be 7 gram. Weight comes out to be 7 gram. This numerical is not tough, students. So bus you only you have to focus the numerical. Only you have to focus the statement, what it is, what it wants, and which formula is satisfying our needs. That we can able to solve question. This is just all about that. Okay. Now we will move to our fourth part. Fourth part. No, next fourth part. Fourth part is 6.022 into 10 is power 23. 10 is power 23 number of nitrogen molecules. Okay. Here is N2 given. N2, that is 14 multiplied 2, that is 28. So M is 28. M value is 28. And I have got number of molecules given, that is N naught. N naught is 6.022 into 10 is power 23. For 23. So W we have to find. Now we will write our three formulas again, that is N equal to W upon M, N equal to N naught upon Na, and third one is W upon M equal to N naught upon Na. Okay, now we will see first formula is satisfying our situation or not. So if we say we don't have value of N, we have to find W. So we can't apply that formula. Now in second case we don't have W, so we can't apply that formula. So now we will apply our third formula, which we will manipulate, that is W equal to cross multiply W equal to N naught into M upon Na. So we will just apply N naught is 6.022 into 10 is power 23 into 10 is power 23, and M is what? M is, that is our 28, and Na is 6.022 into 10 is power 23. So just cancel it out and its answer comes out to be 28. Weight comes out to be 28. So simply guys, one thing you can notice, that when we take nitrogen, weight comes out to be 14. And when we will take N2, that comes out to be 28. Suppose in paper their question comes out to be both parts, so just you have to see that we have to double the answer. Okay, we have to double the answer. Now we will move to example 3.5. Example 3.5. Very simple numericals guys, very simple, and it's very important, and it's also important from the paper point of view. Example 3.5 is calculate the number of particles in each of the following. Calculate the number of particles in each of the following. First one is 46 gram of sodium atoms. 46 gram of sodium atoms. Okay, so we will solve it. That is, weight is given 46 gram. Molecular mass is 23. Sodium's molecular mass is 23. So we have to find, that is N naught. We have to find N naught. So we have three formulas: N equal to W upon M, N equal to N naught upon Na, and W upon M equal to N naught upon Na. So which formula we will apply? We will apply our third formula, that is W upon M equal to N naught upon Na, and we have to find number of particles. So we have to find N naught. So N naught will be equal to W upon Na, W into Na upon W into Na upon m. And W is 46 and Na is 6.22 into 10 h power 23 upon m, that is 23. So just we have to cancel it out. 1, 2, 1, 2. So N0 comes out to be 12.044 into 10 h power 23. 10 h power 23. Very, very simple numericals, students. Very, very simple. So next two parts of example 3.5 is the homework for you. Is the homework for you that you have to try that by yourself. If you find any difficulty, I am going to upload video on that two parts also with the two questions based on that topic, which are our blue NCERT questions. So I want that you try first and then I will upload that video. Okay, so but just you have to remember three formulas and you have to apply that. So thank you guys.